Yeah, I can hear you. Changing my picture.
You got a picture? This is 2 weeks off.
Yeah.
But still, I was caught with my hand in the till. Just the biggest mouth to feed of them all. I'm against it all. Yes, oh, trouble swelling. That's when desire sets me up. I cut my nails to the quick, but still I was caught with my hand in the till. Red-handed.
What's up? Can you hear me, Rod? I think you muted.
I was. Yeah, that was Fugazi. You ever heard of them? Never? You've heard of a band called...
I've heard the band. I've heard the name.
You've heard the name. Let's see. Originally, it was another band. What did they call themselves?
Yeah, I've heard the name back in the day.
Minor Threat. That's the name I'm thinking of. It was Minor Threat. That was Ian MacKay's first band, and he made another spinoff and called it Fugazi. But I'm trying to remember what Fugazi stands for. Do you know? I think it's an acronym, right?
Oh, didn't they?
That'd be something to look up. Fugazi. What is it? I think it's a
like means false, bogus, or inauthentic.
Yeah. Well, I think a Fugazi is like a bad gem. Yeah.
It can also mean a counterfeit, sham, nonsense, imposter.
So I think the band was dedicated to the term.
Can you hear me?
Yeah, I can hear you.
Okay.
Yeah, you're good. Can you hear me?
I looked it up.
Yes,
It's also spelled Fugazi, Fugazy. It's a slang term. It means false, bogus, inauthentic.
I think gemologists actually, when they got a bad gem, they call it a fugazi.
I used to listen to Mind the Threat.
Oh, yeah.
That's why when you said that, I was like, oh yeah, I remember that. It was like skater punk.
Yeah. I got to see him play a couple of times when I was younger. They come to like small clubs in Charlotte and play. That was a long time ago, man. I remember it like it was yesterday.
Yes, what have you been up to?
No, not much. I've been babysitting the grandkids this afternoon.
Oh no. Yeah, my guts are not happy with my food choices of the day. Or yesterday.
Got roll-aids, right? Or
ROLLIDS.
Yeah. It spells relief.
Oof, man.
I don't know if that's how you spell relief, but that was the way they added it. Yeah.
You want me to walk through the chat?
Oh yeah, sure. Well,
Hello to everybody in chat. Good to see everybody. Roger's high energy, and so are we. Oh man, we're both old. All right, hello to the chat. Dirty Ketchup.
Yeah.
Mr. Superside Wonders here. Henry Thomas. Restream.
Don't worry. You got Jim Anus. You got Snyder.
Jim Anus. Yeah.
Miss Snyder. Yeah. I said hi to about everybody in the chat.
Slayer.
Yeah. No, Slayer's gone. He went to bed.
Well, say hello to him anyway. He can watch it. Good to see everybody.
Replay.
This is probably going to be a mishmash of a show. We're just going to kind of mishmash it together and have a little fun with it.
What got my attention was the firmament. So that's what's been bugging me over the last couple of days. Like, it seems like they don't account for anything when it comes to it. They used to when they did experiments and stuff, but they don't do it anymore. If you want to call them that. Observations. They accounted for actual containment. So it's just been in recent years since they discovered space, supposedly, that the firmament doesn't exist anymore.
Yeah. Well, I mean, that kind of blows the whole thing up, don't you think? If
there's a cover over it, yeah.
Yeah, it's just kind of. I mean, when you think about it, well, if there's no container, then that we wouldn't have this environment that we're living in. Obviously, you can't. You're not putting air in. The tire is a container. The air tank is a container. The propane tank is a container. We could just go on and on.
Yeah,
obviously.
Forever.
Yeah, I mean, your body is a container.
Everything's a container.
Yeah.
Love it. Yeah. Anyways, other than that, I mean, I got a couple of videos I wanted to maybe look at, but I thought if you want to, you have a list right in the back you put in here. What'd you throw in?
It's it's a little this, a little that. It's stuff that we were talking about in the last show. It mixes it around a little bit, shows you the effect. Shows a lot of effect on water. It's actually pretty good. The guy has a little RC boat that he's using, and he's moving the boat around and showing you where you're reaching the. This is a little pond. It's not even a big thing, and he does some camera tricks to show you how the boat disappears. It's pretty interesting.
Yeah. Is it Sky Free by chance? Maybe.
Huh?
Is it Sky Free's video?
I don't know. It's in French, so I don't know. The video is in English, but the title is in French.
Yeah.
And they're all good.
Let me get through these ads right quick.
Yeah, it's BitChute. Kind of sucks.
Yeah.
But I've been kind of glancing at that stuff today. I did just because I haven't really done much. I just kind of lazing around.
Yeah. So the name of this one is Just an Illusion. Is that what it's called? Horizon Refractions. John Thor. I think this is Sky Free's video, actually. I'll put it up here on screen.
Somebody reposted it, probably in another country, and that's why the title is in French.
French, yeah. Why not use it? Anybody know how to read French?
Yeah, I could read some of it.
They gave me. I think I took the first part of French in public school, which isn't very. It didn't stick with me. Let's put it that way.
I took one day, and it hasn't done me any good.
Yeah. So. If I lived in France, it might be different.
Oui.
Whatever that means. That's something that the little pig did on his way home, right? Whee!
The natural physics of water are that once contained and undisturbed, the surface will always remain horizontal. This fundamental physical property of water is why it has been used as a leveling tool by builders and engineers for millennia. Whether in a bucket, bathtub, pond, lake, or an ocean, the surface of water at rest always remains flat and doesn't have the ability to show convexity or any shape whatsoever upon its surface. This fact is easily demonstrable and empirically verifiable, but completely at odds with what we are told about the globe. For Earth to be globular and over 70% covered in water, the oceans must be somehow curving around and sticking to all sides of a rapidly spinning ball suspended in space. It is simply impossible to make water behave this way, as anyone can experiment for themselves. Bodies of water will not stick to the underside of a ball and cannot show convexity or any other shape upon their surface. Globe defenders will often point to water droplets, meniscus, surface tension, or adhesion, claiming these are examples of water bending or sticking to a surface, which is nothing but a fallacy of false equivalency, as these only happen at a very small scale, the size of a coffee cup. The claim is entire oceans wrapping around and sticking to the underside of a spinning ball, not a water droplet or the meniscus in a glass filled to the brim. NASA has also recently taken to faking CGI water balls using augmented virtual reality technology in an attempt to convince the public that water can behave this way. This kind of demonstration, done in a reference frame inaccessible to 99.99% of the population, however, is unrepeatable by the world's scientists and skeptics, and is therefore not scientific or permissible as proof of anything. First, they claim only massive objects the size of Earth have this attractive property. Then, as evidence, they show a phenomenon allegedly outside of our earthly reference frame. In other words, they are claiming bodies of water can bend around, stick to a ball, and show curvature upon their surface, but only at a scale too big for the public to recreate.
This world is not what you think it is. This world is not what you think it is.
Yeah, I like John Thor stuff. It's pretty
Yeah,
decent.
pretty good. I like the Aussie boat on the right, because it kind of, it's scaling it down to a point where you can kind of replicate it yourself and see the effect as seeing the reflection of the boat on the water, even though it's a little RC boat. You don't have to go far away.
You get the
Neither
same
do
effect.
you. Yeah, you don't need you don't need to be going out in the ocean and doing it either. You could do it in a pond, you could do it in a garage, you could do it in a long parking lot. There's lots of things you can do to get that effect, and you don't need crazy. Yeah, that's why I like those ones, because they kind of show you on a small scale that you can do it yourself. You can see the effect yourself and record it. Very simple.
You could do it in a boat. You could do it in a car. You can do it anywhere. You can do it here.
Yeah,
You can do it here.
anywhere.
You can do it far. Yeah,
Anywhere. Yeah, I like that idea. I like the idea that they can scale it down so that you don't need to go across the ocean to do it. So it shows that it's not something that's over insanely complicated, that you couldn't come up with similar, or if not the same effect yourself.
Yeah, it's naturally
Like using a kid's toy.
Don't do that with a kid's toy. Yeah, I like that, the little miniature RC ones. I've seen those videos before, and John, I disagree with John Thor on a couple of things, because he's a full blown etherite. So he believes that the ether is absolutely a positive thing. I can't prove it or disprove it either way. And I don't think a lot of people just adhere to it. That's the only thing I don't agree with them. Yeah,
it's okay. We're all going to be different. I mean, hey, I watch Vibes of Cosmos.
The Vibes of Cosmos.
Everybody craps on me because I do, but there's a lot of similarities. I find it interesting. I don't hold it up as
This is science.
sacrosanct. Yeah, I mean, it's just an observation.
Makes us. I pulled up another one. I'm gonna put it on the second one in your video. So like 19 pilots address flat Earth questions. They say no commercial pilots of flat earther, but I think they are kind of deep down in a weird way.
Yeah. I mean, if you've been flying for 20, 30 years, you know it ain't. You know
it ain't a ball.
Yeah, you know. I don't want to out him, but I have a cousin who flew helicopters. He was in Vietnam. He flew helicopters. I asked him once, and he didn't even answer me. Just looked at me and just kind of giggled a little bit, which was the indication of yes, but without him saying it, because he worked for a big company for a long time. I'm sure he could tell me some stories, but when I asked him, he just kind of looked at me and give me a look like, do I even have to say it?
Yeah, I know. I guess.
He's a test pilot. After he was out of Vietnam, he tested brand new helicopters. They bring them up as high as they can go. They do everything you could do to them. That was one of my cousins. Real deal, no BS.
I don't think John Thor's his real name. I'm sorry, I had to address the chat right quick. No.
Probably
And
an
Henry
name.
I want to say Henry. Nobody cares if Monkey made a video about Vlad. I know. If you're out there making videos about people, you're basically making fun of them.
He should be making videos proving that we're following a curvature. That's what he should be making videos and trying to prove 24/7. Not trying to focus on people. That's what he should be doing. That's what they all should be doing.
There's a fallacy there, and it's been going on since I've been here. It's called ad hominem fallacy. You attack the man and not the argument.
Exactly.
Yeah,
he should be.
Sad.
They should be taking that. They should be taking the money that they're trying to offer to make lol cow fucking material, and they should be getting on a plane and going on there with equipment and finding out that your body does not follow a curve. They should be getting on a plane and flying from one side to the other. They could be really easy. They could, if they're on the East Coast, they can fly from the East Coast and go all the way to Asia. That would prove everything, but they're not going to do that, because if they did, then it would show them that they're idiots, that they believe that they're following the curve. And that's the problem why they don't make videos like that. Right? They're not going to ever, because if it disproves what they're saying, then it screws them. So they're never going to show you that. But they're going to turn around and make a video about people when they should be just proving what the hell they're saying, and they're never going to do it. Because if they did it, they would realize real quick that your body's orientation does not change. Once it goes up, it flattens right out. And then if they kept on that trajectory, if you factor in the curvature between the 2 points that you're flying, well, you'd be smashing into the ground. And that doesn't happen either.
Yeah, it's true. Brian's Logic's got a challenge out there. He did all the math for him. He figured it out, and he's like, you go from this airport to this airport, and you'll have to declinate to this degree when you even land. And he said any pilot wants to take his challenge, he will give them a certain amount of money, but nobody's came up on this challenge yet and take the flight. We're gonna fly with the curvature of the earth and land on a runway said miles away, but nobody's done it.
Then I hope they have life insurance. They're gonna need it when they're done smashing the plane into the ground.
You know who Woofy 6040 is, right?
Yeah.
He uncaged his gyro on a table, and he demonstrates how it actually works. It was a simulated flight, and the gyro will find the horizon again, but it takes forever. My challenge to him was, next time he gets up in his aircraft and he flies, it uncages the gyro from his altimeter and tell me if he gets to where he's going.
Use a mechanical one. Use a mechanical gyro and then do it. Right? Then we'll see what happens when he tell him to call us when he hits the ground.
He will.
Tell us to call us from the hospital when he gets there. Jesus.
In a neck brace. I tried it. It didn't work.
Tell him to call us when he wakes up in the ICU.
Yeah. But that proves gravity, because you can uncage a gyro and it will horizontal out. But you try to take that up in altitude without it being caged, you're going to lose the horizon you're at. You're going to end up hitting the ground eventually.
Yep. Follow the curve. Do it.
I think
Make
somebody
a
tried
video.
that one. Make a
Yeah,
video.
and they crashed. Yeah, and they fucking crashed. I think what you were talking about it.
Yeah,
You're talking
some
about
dude
a lot
did
of.
it.
Yeah, he's
Yeah.
like, oh shit. Yeah, no wonder why you're on the ground because you're following a curve that isn't there.
Yeah.
It's that
There's this
simple.
big gap that opens up in front of you at 1.8.
Well, they'll just smash into the ground. That's all. You're just smashing the ground. Figure out that curve calculator and say, okay, at this point we should be smashing into the ground. When you get 100 feet from the ground, then you need to fucking pull up. And that means that your shit don't work. It's not going to work. It's very simple. I mean, anybody can do it. Those guys are willing to kick thousands of dollars out to get people on there to make. Why don't you use the $1,000, get on a plane, take some angle meters, and figure out what the hell it's doing. Show what it's doing. Show everybody what it's doing. That's all they could fix the problem, and they could do the whole thing and prove us all wrong.
I think Henry's out there begging for a wrench now. He wants to post a link for Snyder. Ooh, look, there's a guy named Bob North here. I don't know who Bob North is. They don't look like
I know
a
his
real-
brother, Bob South.
There you go. Robert South. He's out there. It's too bad Brian's logic can't do math. He never touches a calculator, doesn't know how to do math at all now. And he's never done any calculations either. He just measures things.
Yeah, I'm not really great on the whole math thing either, but
Well, Brian actually does good math to a point. They just don't agree with it because it's not calculus.
yeah.
Because we got to do calculus to find our equations. You got to pre-assume your radius and so on and so forth.
Calculus Earth.
Yeah. Calculator. Let's check out these pilots right quick.
Yeah.
Flat. This is flat. Thank you very much, mate. God bless.
A man asked the pilot if the Earth is flat.
Can I talk to the pilot, please?
Right here.
You're the pilot?
Hi.
How long have you been flying for?
Like for Delta, 21 years, but maybe like 30 something.
I want to know, because they say the pilots know a lot. Do you think the Earth is flat or no?
I know it's flat.
You know it's flat? How long have you been flying for?
You can redact your statement now, sir. No, I'm just kidding.
Yeah. They pulled him right off of that flight immediately. I'm like, hey, you. Yeah, sorry, but you've been grounded.
Oh, yeah, that's funny.
For 30 years.
And when you tell people that, do they think you're like crazy or no?
Only one person.
Only one person?
They built it for a flat, stationary Earth. And my goal is for some young fighter pilot to listen to what I just said, go out tomorrow and set the bottom of your L strobe on your altitude, run it out there to 80 miles, and that bottom altitude on your cursor will stay the same.
Are you a pilot?
Yes, sir.
One question.
Okay.
When you descend in the air,
Yeah,
do you dip or do you go straight?
it's straight.
Straight?
A little more with the nose out. That's it.
But straight. You
Straight,
don't dip
yeah.
into the...
No,
Okay, thank you so much. I appreciate
you're
you.
welcome, sir. All
Have a
right.
great day.
Did you notice any curvature while we were up there?
Curvature? No.
No, there's no curvature?
It's just all flat.
The pilots. Is the earth flat or round?
Flat.
Thanks. I'm with you.
Pregunta controversial. Hay un debate ahora en YouTube especialmente en el que las personas se cuestionan que si la curvatura de la Tierra es observable o no es observable. No, a las alturas que vuelan esos aviones. Usted no va haciendo ningún ajuste, va como si fuera parejito, sobre terreno. No, pero sí tiene unos 2 grados más alto que normal, depende de lo que del peso del avión. Ok, la nariz va hacia arriba. Sí. Pero no tienen que buscar la curvatura. No, vuelan como si fuera sobre un plano. Sí, es lo que trata de hacer el avión. Bueno, muchas gracias. Mucho gusto. Okay. Sigue bien. Hasta luego.
Because they tell us, that at least in the U.S., the ground's moving at about 700 miles an hour left to right. And I was thinking that's kind of odd if you're landing going north, or moving in the north direction.
That's not, no. The ground looks to us like it's standing still.
Yeah, not an issue, huh?
Yeah, no. You could probably see the Rockies from...
I just want to touch on something. This guy, bob north. Do you know how the lift effect works? Do you understand why they have to put the nose up to keep the lift effect going? They keep the horizontal straight, but they have to declinate the nose at a certain degree above it to maintain their lift, and they have to keep a certain speed to keep it there. But the horizontal never dips. But if you're actually keeping that lift, you'd have to dip your nose down to actually go around the ball. That would actually have to happen with the lift effect. Do you understand that? Just thought I'd point that out.
They could adjust it with speed. They could
Yeah.
keep the same elevation, meaning they could set it, then they could just drop the speed. And you know what happens? It drops.
Mm-hmm. Yeah, but
So-
they never change speed though. Like I'll give you, for instance, a flight from anywhere to anywhere, they maintain one airspeed.
Yeah,
For the
yeah.
most-
I mean, it's fixed. I mean, because they're using autopilot. So I mean, all the flights I've ever taken, and I've taken quite a bunch, not to any European places, but going from where I am up north and going down to going down to Florida, that thing went up and angled up. Every single one of them angled up. It flattened out, and it stayed that way. Every flight I've taken has been nonstop. No stops. So no secondary. But
they would still have to. They would actually have to drop if they were going over a curvature so many feet per second. That would be an absolute fact. But they never do that.
The other thing also is, even if they took off, if you think about the shape, and they took off, let's say they climbed up to their altitude, they climb up to the altitude that they're going to flatten back out and then hit autopilot, right? Now, if you were going, say, from the very top of from the absolute tippity top of the ball, say you were taking off, okay? You're taking off from the magnetic center from the north, and you take off, you climb up a little bit, even if you only went up a couple 100 feet, and then just leveled it out, okay, and kept it flat, meaning flat. You take off, you go up a couple 100 feet, you flatten it out, you set it. What is happening as you're flying off of the top of the ball without you correcting down? You're gaining altitude because the ground below you is dipping away. It's dropping away.
Yeah. So the next excuse you're going to get is, it's all leveling out to the center of gravity. That's where they get their level from, but that's not so.
Well, I mean, from a plane to the ground, they have indicators built right into the plane. So if the plane starts to nose down, to say they're getting, I mean, we've all seen emergency stuff where the plane has lost some kind of control and it's getting close to the ground. It starts giving you warnings about being close to the ground.
Yeah, well, they use sea level as an average height, and the altimeter is actually at a height above that. In order to maintain lift above that height of sea level, that's where the actual measurement's taken. It has nothing to do with the center of gravity. They like to throw that shit in there because it's a ball.
Well, it's physical. I mean, they're getting physical measurements. I mean, they can get So I mean, basically, if you flew off the top of the ball and you just went straight, well, you went flat and level. Is the word I'm looking, not straight, because you can go straight over a ball. You can go straight over any surface.
You can do a straight line, anything.
Yes, you do straight line and anything. But flat and level is different. And if you're going off the top of the ball, what's happening is the plane isn't nosing down. You're going flat and level, but you're gaining altitude. How would you gain altitude if you're flying flat and level? Well, because the underneath is shaped, it's curving down. So everything from where you took off is curving down no matter what.
It's
That's fucking simple.
Henry's out here touting something he doesn't know anything about. The coordinate system that they use, that's all that is, by the way, Paul. Your globe coordinate system is based over a flat plane too. I hate to tell you that. It's not that they don't fly the planes and the autopilots fly. They had to learn how to fly to begin with. They had to log so many hours of flying without an autopilot, dude.
Yeah,
you're nuts.
There's been times where those guys have lost instruments, and now they have to fly it manually by eye. They have to fly it with no instruments whatsoever, by just visual. Was it VFR?
Yeah,
and with VFR, where all the electronics have gone out. I mean, manual planes. Not talking these big jetliners are electronic nightmares if the power goes out and crashes.
And how many gyros they put on those things, dude? And the NTSD data is ran off like, I think, 6 gyros or something like that. I forgot the name of the system, but I mean, it still references the same horizontals to begin with. Yeah. So all you're talking now is jargon.
Yeah. Just
think Come on, break out the pendulous veins. I see spin.
My,
He's out here talking pendulous veins.
my thing is the physical. What's the plane physically doing?
Mhm.
If that thing was nosing down from the top, let's say you're on the top of the globe, you take off, and that thing is constantly nosing down. What's happening to your body when you're sitting in the seat? Your feet are starting to go behind you, and the top of your body is leaning forward. Just like if you were going up a hill, what would happen when you were driving up that hill? Well, your feet would be moving forward, and the top of your body would be leaning back as you climb. The same thing would happen as if you were tilting forward. Your orientation of your body never changes. Every flight I've ever been on, I've never said, oh, wow, we must be climbing up the top of the globe. And here, now we're on a flat spot. We must be in the middle of it because now we're starting to dip down. That's never happened once, ever.
Yeah.
Ever.
Oh, this makes me want to start talking about Coriolis effect. Does anybody know what the Coriolis effect is? Come on, break it down for me. How about the Coriolis force? Let's go with that one first.
Yeah. My God.
Me and my reference frames. They're ruined. I've never had I don't go with reference frames. I have one reference frame, dude. IC spin, you have like 30 of them, I think, within your mathematics, which are unnecessary.
I don't think these guys have ever been on a plane, because if you were in a plane, you'd realize real quick that the distance that you would have to travel, especially if it's a very long flight, you'd be smashing into the ground.
I've flown in everything from Cessnas to 767s, man.
So have I. I've been in helicopters, multiple.
And did you ever account for Coriolis? No. There's no such thing, anyways. No. Coriolis is an appeared phenomenon. It just happened. If you're in one reference frame, you'll notice the object curving due to your spin, which we don't see. Therefore, we're not spinning. You should just go look at the NTST data that we actually pulled up. We can actually prove that it's horizontal for over 2,000 miles. No doubt. Anyways, let's look back to the pilots. I'm getting tired of reading the chat. It's become a troll fest in there now.
Yeah.
Kansas.
Wow.
But it's a clear day, but if it's smoky or hazy, obviously we can't see.
Excuse me, guys.
Hey.
I have a question for you.
Yeah. One of us can answer it.
Do you guys adjust for curvature as you're flying through the air? You know, the Earth is supposed to be a ball, right?
Yeah.
So should we be dipping down the nose of the plane to compensate for the curvature, or do you guys or do you fly on over a flat plane?
Well,
he's like, we're not allowed to answer.
Over a bowl.
We're not allowed that.
Not that.
8 inches per mile squared is the official story of what the curvature drop should be. So a distance
rise over run.
If you're 8 inches from the shore on a beach, and your friend is rowing his boat out 1 mile away, the boat should be already hidden by the curvature. You guys don't see curve; you see horizon at eye level.
No, I mean, if you look at more of a curvature of the Earth, and we're on the perpendicular. We're just on that tangent.
So really,
we're on a tangent now. You hear this guy?
Earth's flat.
Sorry?
Earth is flat.
Yeah, we know that.
Everybody goes to the tangent.
Stationary.
Every little point.
Well, you know that. You guys see the horizon at eye level, and you have to understand that if you're on a ball, as you rise from the ball, you would have to look down to see the horizon.
Yeah.
You don't ever see that. I look out the window of the plane, and I see horizon as far as I can see.
This guy knows
flat.
a little bit.
What's different from the front?
Even from there.
Yeah, because you're tilted up.
Your windows aren't that much different. Earth is flat. It's a big lie. You guys should look into it. You know it's flat. You guys fly over it every day.
You fly over it every day.
I know.
Do you say that it's flat?
Yes.
Yeah? Thank you very much.
Is there any more pilots up here, or is it just you?
Just me.
Just you. I got a quick question for you.
Yeah.
When you're up there, come on, cruising altitude, do you all have to adjust for any curvature of the Earth while you're up there?
Great question. No.
You don't?
But I know.
Because my understanding is you're like on pretty much like a parallel sort of flight, other than takeoff and landing, correct?
Yes.
Okay.
So yeah, I guess it's more vertical, so we're not curving at all. So we're just going straight up, like 20 degrees maybe. Level off, and I never thought about
real quick for a second.
Atmosphere works with the curve in the Earth and all that stuff.
Well, if you think,
yes, sir.
The angle that they would have to go would be lower. They would have to when they would first take off, that angle would be lower from where they're taking off. Well, the angle that they would have to land at would be in extreme. Think of the angle that they would have to land at, because now, well, I don't know. I'm thinking weird on angle stuff, on physical stuff. But I mean, if depending
Yeah.
on the angle, think about it. If you were, say, in the Midwest, your body orientation or the plane's orientation to take off wouldn't even be flat. It would be tilted. It would be tilted to the right. So you'd be taking off sideways, almost
Ways,
sideways, like your angle that you would have to take off. You'd be pulling off of the side of it. Like, that's why I'm saying, if you think of the physical things and you think about the physicality of it, you think how stupid it is. Like, if you were down below the equator, you'd be taking off to take off from the land. You'd be going down to take off. So I mean, think about
I'll give you a good for instance. I talked to a pilot a long time ago when I was really young, and I asked him, like, when we take off, like with local continental flights, like for instance, like if you're flying from Chicago to New York, what they do is they get to an altitude and they take a trajectory, but they actually use the height to get speed and get further. So the higher they climb with the bigger jets, they don't actually they keep the horizontal level, but they kind of just they do a circle out of it. They fly they don't just within like US. Let's say if I was flying from like Tulsa, Oklahoma to Atlanta, the higher I get, the more my trajectory I can angle it to where I'm going. I can get a further distance higher I get, like a better angle at it. So they do that kind of like a leapfrog thing with the commercial plates.
Yeah.
But if you're flying smaller craft, yeah, you got to keep your horizontal completely level to maintain flight. But with those bigger jets, they can get a higher altitude and they can keep it at that pitch and then kind of dive to their location. Higher, yeah. But it doesn't make much of a difference. I mean, the longer when you go across the oceans and stuff, they have to maintain that level above the ocean. So they have to keep it horizontal and keep applying the gas, you might say.
Yeah, well, I mean, they could throttle it. I mean, if they would have speed it up and not move and not nose it up or nose it down, but keep it at its level, but then just throttle it up, because it has to have a slight uptick. The nose has to be just slightly above to keep the lift. I mean, it's doing it automatically anyway by the electronic systems and the gyros and all the other bullshit that it's all doing. But I mean, like I said, if you had to physically fly it and say, okay, we're going to VFR it, we're not going to use any of this crap, and we had to just literally fly this thing, like I said, a Cessna, or what do you call it? When you think about the mechanical part of it, and you're thinking, okay, mechanical flight, you're doing it with no instruments. Well, shit. What's your point of reference at that point? At that point, it comes down to, okay, let's look at the wings. All right, we're level. Okay, let's see where we are. Like, remember we were reading that PDF about how you can get disoriented? Yeah. And I mean, when you're thinking about it, that the physical part of it kind of comes into it, that, okay, now you're physically looking at stuff and you're physically saying, okay, let's look and let's see where we are. You've got no instruments to look at. These big jetliners, everything it's doing is all electronic, every single thing of it.
You put the quarter in it and you ride, dude.
Yeah, that's it. I mean, I have a flight simulator. I have a couple of them, and I got so good at the flight sim thing that I could do the Boston to LA, and basically manually fly that thing, pull it up, just like you were saying, about 20 degrees, and pull that thing up and get it up the flight, and then just go tick, tick, tick. There we go. Yep, autopilot, and I could just turn on the speed, so that way it does what it's doing. It's doing the exact same thing. But when you think about the physicality, when you think about the global physicality part of it, say you weren't taking off from the top, say you were taking off from the equator. Well, the plane is sideways when it's taking off. So
have you heard the one about flying west to east or east to west at the equator? How at 500 miles an hour, if you're taking off east to west, you're flying with the rotation of the earth, quote unquote. But if you're taking off west to east, you're flying against it. So
yeah,
you're like basically in physics to say this, you're actually flying backwards.
Because the underneath of it would be going faster than you're going. So
that's never been proven.
Technically, you wouldn't be going anywhere.
Yeah, it's like standing still.
Moving at all. You'd just be sitting there surface, shit underneath it is moving. And if you were to open the window and put your hand out, how the fuck is that working?
Oh, it's all Velcro gases to the surface of the earth.
Oh, God. It's such a mind fuck in every way you think
It is.
about it.
Well, their whole model's a mind fuck, dude. If you really look at it.
I'm telling you, man. Every time I kind of sit and just ponder on it, I think, my God, what a shit show.
Well, their space model falls apart not that far away from their so-called the sun and the moon in its own self. Once you get out into the universe, it gets weird. Like things don't do what they're supposed to do, even in their model. So why don't they just throw away the model itself, the Copernican model, just get rid of it and start over? They're not going to do that.
No.
They've already printed so much science books, so much consensus to do with their pseudo experiments that it's nuts. And there's so much money they waste in time. Yeah. Well, you can get a grant from NASA tomorrow. You can get a $250,000 grant to do something. I'm sure if you give them a bullcrap story, and then you can go to school and you can invent something that goes on a satellite somewhere that supposedly does something.
My God.
Yeah, I know.
I mean, I don't have a doubt that they can't go up crazy high, that they can't fly, take a balloon and get something up insanely high. I mean, that is without a doubt. I 100% agree that they can do. Do I think that they have some kind of, they have 100% free floating? No. I think that there's still some kind of force, even when they go insanely high. Do I think that they have suits that can pressurize and do all that stuff? Yeah, to a certain height.
Yeah, but there's no telling what kind of pressures are up there too. I have no idea, and neither do they. But they always, whenever they come back with any missions, they're spot on no matter what. They've never been wrong.
Yeah. Well, they're also making a lot of money. So
and they got to put on a show.
Yeah.
Let's get back to the pilots.
Think about it. I've done some research on it. There's a formula, 8 inches per mile squared is what the curve is supposed to be, spherical trigonometry. And if it was actually that formula, we would have to dip the nose a half a mile every minute to stay around the ball. So I just wanted to ask you, as someone who's up there, the plane doesn't do it automatically. You're not adjusting anything, right?
No,
it's just flying straight.
Even talked about it in 30 years I've been flying.
Yeah, it's funny to think about.
Maybe the gases move with it.
Well, that's what I've heard as a working theory. Is some people think that gravity does something for you, but I mean, I guess the common question goes back to is like, how many parallel flights does it take for you to go around in a circle?
Very interesting.
You know what I mean?
Yeah,
take a look into it.
Yeah, we're going to start doing that.
Yeah, all right, man. Have a good one. Hey, guys, you mind if I ask a question real quick?
Yeah, sure.
So, when y'all are flying up there, do you account at all for the curvature of the Earth?
Well, we do when we do what we call getting directs. Our navigation system off of we have IRS's internal revenue initial reference system.
Just do your taxes?
That the airplane, it can do itself.
So it does it itself?
Yeah, it doesn't matter if we lose our GPSs, but we also use GPS satellite and we use ground-based. And when we go direct, we no longer fly direct to a point. We arc, because believe it or not, because of the marble, it's closer to arc to a point than it is to fly straight.
So if the Earth is 25,000 miles in circumference, we have a curvature.
No, I made a point to that. Remember, I was talking about how they do the arc.
Yeah.
So they're not making a reference to any point. They're getting a GPS coordinate. Don't get me wrong, but it shortens the distance because of your height. It has nothing to do with not really just distance. Your airspeed. It takes less time to get there. That's only. It's not a distance. It's the same distance you fly. So when they do those arc patterns and they fly up high enough, when they do like intercontinental flights, but not intercontinental, but continental flights from one place to the other, they don't do that over the oceans. They can't get that high above it, but it's too far to go, especially over the Pacific. It's like incredible. They have to maintain a higher level at 31,000 or plus. Yeah. Anyway, yeah, I know it's nuts, but they're just making a shortcut out of it, you might say. And
Yeah.
great circle routes are shorter than the rum lines that they actually have. If you look at the rum line destinations, like the original coordinates they did with the rum lines when they first started navigating with ships, they turn those into great circle routes. They just shortened them. That's all they are. They're rum line distances from one meridian to the other. That's all it is.
I like how we said, oh yeah, well, we do ground-based GPS.
Of course, he had to do that in there because they're not all satellite at all. Very little from satellite. They say it's satellite, geocentric satellites, but I'm not sure. I'm pretty sure it's just the geostationary balloons that they put up there.
Probably in certain points.
Yeah,
probably in certain points.
Most of it's done ground based. I mean, most of it. Like they said, 90% plus is all done with ground based stuff.
Yeah.
Yeah, and they just had the coordinates the coordinate system that they adopted for the globe, which doesn't pan out, and that's why they're guarding the south. That's why they don't want me to go down there. That's why they have those trips in the southern part of the world that you can't go to places. If it was free and all the coordinate systems worked properly, if I took an azimuth and went down south and used it in bound mount coordinates, and I'm in a place that nobody else has been to before.
Yep. Truth Warrior said, if the Earth was a ball, you'd be flying nose down the entire trip.
Yep.
And yes, you would. The second they would get up to elevation, the elevation that they need to set, then that thing would be nosing down. And at the same time, your body's orientation would be changing. So you'd be following the curve. Well, so wouldn't you? So that means that your body would be changing as you would follow it. So where you would be sitting in the seat, your face would start to move forward if you went from the top to the bottom. If you went from the bottom up, you'd be taking off upside down and going down to gain altitude.
Yeah. And they maintain, Andrew saying, why would they allow money and control? Absolutely. And the whole thing is the Admiralty law at the sea controls trade. So if they control the coordinate system and have you go to these places, they can tax you. They can make sure you have product for them, and you got to walk a line. That when you dock and you have to unload your ship and stuff, there's so much stuff you got to go through with your manifest and everything. You got to they have you under your thumb your whole life, whether you're at sea or on land. That's the whole point. That's why they do this. It's total control. Yep. Let's see what else the pilot's got to say. He's on round 2, right?
Yep.
8 inches per mile squared.
I'm gonna take your word.
Ride with me.
I believe you.
If we're riding at about 500 miles an hour, roughly 35,000 feet, in order to stay over that, the plane would have to dip a half a mile a minute. Do you know what that would feel like up here?
No.
It would feel like a lot of dipping.
Are you gonna launch satellites when you or do you do
No,
that?
but I know people that actually launch we launch high altitude balloons.
Very cool.
120,000 feet, level plane.
So say that again. In order to stay at the same altitude.
Right. So if it's a 25,000 mile circumference ball, 8 inches per mile squared is the formula. It's spherical trigonometry. You have to kind of go do the math to make sure it works out. But if you're traveling at that speed, we would have to dip a half a mile a minute just to stay over that. So it would honestly be like we were kind of dipping all the time. And as you all know, the nose is slightly up, flying level. So my question is like, how many level flights does it take to go around the ball? We're not curving on the way to France. We're not curving on the way to New York.
We are.
Are we?
Yeah.
Yeah, dude. I mean, the forces equal out, right? Like the acceleration.
Oh, yeah, of course they do.
Gravitational force.
All right, now is the plane doing it or is gravity doing it? Because now we got two different things.
I think gravity.
All right, one more and I'll let you guys go. The Earth is moving at east to west, 1,000 miles an hour, right?
I'll take your word for it.
What's it like landing on a runway north and south if that runway is moving 1,000 miles an hour east?
Well, we're moving 1,000 miles east.
We're moving with the Earth? So the only thing independent of the Earth's spin is sniper bullets, not balloons and airplanes. Think about it.
I love it, man.
Think about it.
All right, bro.
If your experience will tell you you're flying over a stationary plane, just forget what you're taught. Just get the wheels turning. Y'all have a good day.
Whenever you fly your plane, do you ever account for curvature?
No.
Do you ever account for Coriolis or Earth spin?
No.
Do you ever see the Earth curving?
No.
Does water find its level?
Yes.
Does it always find its level?
Yes.
Okay, so water always finds its level. Does water conform to its container?
Yes.
Y luego, además, aquí aparece
como si fuera, no sé cómo le llamamos a esto, un anexo, un añadido, algo que se cose.
Sí, exactamente, un parchecito, que me recuerda a una persona muy especial. Plana y estacionaria, ¿se ve?
¿Plana? ¿Sí? ¿Y no tiene algo de achatamiento? ¿No se ve no? Eso es cuando ya nos vamos a la órbita, ¿no?
La curvatura se ve cuando la cámara es de ojo de pez, como la que llevaba el que se tiró de Red Bull.
Sí.
Ahí sí que ves la curvatura, pero si la cámara es una cámara normal, se ve todo recto. Normalmente volamos a lo máximo, el techo del avión es 41.000 pies, que son 12 kilómetros 800 metros o algo así.
Sí.
Pero normalmente volamos a 35, 37, que
¿Y a esa
son
altura no se ve
10...
la curvatura?
No, hombre, no, según... a ver, yo he volado con el Lear a 47.000 pies, con el Lear 10, el jet privado, que son unos 13 kilómetros 600 o algo así, y tampoco.
Did you notice any curvature while we were up there?
No.
No? What did you see while we were up there?
Just the blue sky, white clouds.
Yeah, is it flat or?
Pretty flat.
Pretty flat?
Yeah.
Okay, thank you.
Captain, someone wants to say hi, is that okay?
Oh.
Do you adjust for curvature when you get up to a certain altitude?
Well, yes, when you see the sun coming up on the horizon, but I don't know if you will.
But the plane stays at an even pitch throughout the whole flight.
Yeah.
So I mean, not too much curvature to count for.
No.
More flat than anything.
Nope, you close your eyes, you won't have a clue.
True. More flat than anything?
What was that?
It's more flat than anything.
Yeah.
Oh, yeah.
Thank you, guys. I appreciate it. Thank you.
Flat or a ball?
Flat.
Not a ball.
I think it's flat.
Yeah, me too.
Pretty flat to me. Too.
It certainly does, doesn't it? And you've got that flight in.
Excuse me, do you mind?
Hey, how you doing?
Very well, how are you? So, you know how we just took a flight of descent?
I like that graph.
It is.
Did you have to compensate for curvature? So, did you just have to compensate for curvature due to the flight of descent as we landed just now?
No, not necessarily. Yeah.
Why would
All right,
you?
thank you so much.
Good night. There's somebody named Wang's 2 feet that wants to ask me. He wants to join.
So
Yeah.
the pilot just told me that the Earth is flat.
Hey, I just want to say thanks.
They do it all the time. I want to address Wang right quick. What's your question, dude? You can type in chat.
Yeah, you can type it in.
Yeah, if you want to know about Antarctica, hopefully I'm going to get a job down there next year. And yeah, 2 stinky feet. Hey, Scott, good guy. You don't want me. Most of people like they'll say they want me to go, but they want me to go on their pre-assumed penguin tours and take the coordinates that they want me to go to make these observations that I would rather actually be able to go freely, but that ain't going to happen. But if I can get down to like the 90th parallel and actually observe for 2 weeks that whole solstice period and do a live stream in the process, are you afraid that I might see something that would debunk your globe? That's what I want to know. I think that's really what you're really. Yeah, I'm not making it harder than I need to. I'm not going to just hop on and go down to Union Glacier or go to like some coordinate system you got laying out for me. Like go to this part and you can do all the observations you want. Now I'm going to go down there during solstice where I'm supposed to be at for me to notice that it's not the same in the north as it is in the south. There's not a 24-hour sun for like 2 months of the period like it is in the north. That's what you guys need to reaffirm your belief. And that's why it's so hard to go do it. What did he say? You don't have to be there on the solstice. Why not? And you're going to hear give me some more predictions. Which longitude and latitude am I going to go to see these so-called 24-hour suns? I could just make a call to somebody who lives at that place and ask them if they get 24 hours of sun. Make a video. Why hasn't that already been done? And don't tell me they already have, and we've seen them. Those are crap. I need a live feed. Nothing you can manipulate.
Yeah, no CGI shit. No
time lapse photography.
Yeah, no piece together crap. No game graphic junk.
If I just go do it myself, there's no problem. I don't have any issues.
No custom chops, no lines in the photos or in the videos, no sun coming up between you and your camera, and it
no
not
proof
being
that I
blocked
go
by
there
your
at
head.
all.
Yeah, not that a camera tripod leg can completely block the sun.
Yeah,
you know what I mean?
Nothing. No questions asked.
Just
straight up
ridiculous,
do it.
fucking ridiculous shit.
Now Bob's over here quoting Flats. Now Unreal Engine. What about Unreal Engine? That was just a hypothesis.
Yeah.
Oh, man, these people. Hey, Scott, I sent you a link if you want to come in. It's in your text. I'll play the rest of this thing.
So it's smooth flight.
Right.
I did have one question. Is there like a specific angle of downward tilt you have to fly at?
3 degrees.
3 degrees for the curvature of the Earth?
Oh, for the Earth?
Because,
No, we just fly over the troposphere.
Really?
Yeah,
But
yeah.
do you have to keep like kind of going down because?
No, you have to nose up.
Really? Maintain lift.
Because I was reading some stuff on the flat Earth that made a lot of sense. Have you looked into it?
Which one?
I was reading a lot of stuff on the flat Earth.
Yeah, they have to keep the nose up very, very slightly.
It's true?
Yeah.
Okay, all right, cool.
All
Hey,
right.
God bless, brother.
All right, have a good one.
You too.
I'm a fellow, Casey Josh, I'm a fellow just PPL pilot here.
Yeah, nice.
I've got a couple of serious questions to ask you.
Okay, here we go.
Yeah, there's a good time.
He knows it's coming.
Yeah.
Curvature.
Curvature?
Yeah.
Yep.
We don't allow for curvature, do we?
Yeah, for anything, not for you usually.
No, we're round, we're a disc, aren't we?
Aussies.
Round and flat.
Yeah.
Sorry. Hey, look, honestly, quite seriously,
Yeah.
we are, aren't we?
Yeah.
He probably gets that question a lot.
When I talked to the pilot I talked to, I didn't ask him anything about curve or flat Earth. That's how we fly between places.
There's Era's book. Era Landucci's pretty good, man. He's an alright guy.
I actually have this on PDF. I have his flight. But there's a little couple of discrepancies I would have worked on. But I mean, for the most part, it's pretty good. And it doesn't matter what kind of lens you use, that's just all optics. That's not physical, Depends on how far you can see with it. That was a nice little video.
Yeah, pretty
now,
good.
what was the third one you put in there?
I think it's more of jeez. I
No,
think
we'll
it's
get it.
check it out. Yeah, look at it. They're all three of them were good. That one was good. I like that one just because it put some stuff in the middle of them talking to the pilots too, which I thought some of them were pretty funny because they give you a look like, oh, here we go with another flat Earth question. They give
getting
you
a
a
lot of-
look like, oh, here we go again.
Oh, why do I have to answer this?
I'm
Hey,
sure.
how
That,
you doing?
oh man, you know how many times a year they probably get asked that? It's got to be thousands of times. It's got to be because there's no way anybody walks like. I mean, the average person will, but the people that kind of know would probably. I mean, I'm sure now they're probably pretty smart to it and probably just don't, some of those videos look a lot, those when they talk about what do you call it, look a little bit older, you know, and I'm sure now they probably have them under some NDA or something, you know what I mean, where they're like, don't talk about this.
They get enough questions now that it's become it's been brought up. I'm absolutely positive. And yeah, dude, what are you saying about your time lapse at high footage and all that shit? I don't really care about collaboration. I'll tell you what, when I get done in Antarctica with my live stream, you can answer that question when you get done.
Yeah.
if I get it, and I'm absolutely positive that I'm going to lose the sun over the horizon within a 20-hour period. That makes sense. Period with the sun circuit. So
yeah, like I said, they were there. The sun was spinning only over their head, but yet the sun came up here.
Mm-hmm. Yeah,
so
of course,
on the pizza, it doesn't work that way. That thing is going around, it's doing its circuit and it's spinning around. I saw the sun come up, it came up every time. That means the sun physically did its thing like it did before they went, and just like it did after. So I don't believe it. Just because I've seen it all my life. I've seen the sun come up every day. I was on the ocean. I saw the sun come up every morning. I saw it go down every day. It's not like all of a sudden it decided to just spin over your head and not come out here, because that's how it would work on an FE model. On the globe, there would be even bigger problems.
Oh yeah. And they have to have that 24-hour period there where it stays above the horizon to fit the model.
I know, but
it is. Oh, let's get this. This other one was like a Sky Free video too. It's in French.
Yeah, all three of them were. I don't know if it's the same person that put them out, but I noticed that they were all in French. But I found it on the keyword, using the keyword on BitChute. So I was like, oh, wow, new ones. But I was thinking, okay, maybe these videos are in French. But when I watched them, I realized they're in English. They're just French titled, you know.
Mm-hmm. Oh, well, I did a video on it. I did a little bit of a touch on like the tropics and stuff, where their markers are on land and stuff. They're off from where they're supposed to be, and they actually kind of admit it, and they kind of give a nod like it's a joke.
Yeah,
like the Tropic of Cancer, Tropic of Capricorn, like they're not really. They don't have a straight line on them, and I don't think you can get a straight line at the equator neither.
Well, that's because they're screwing the longitude and latitude line once you get south of the equator.
Yeah,
they converge. They're angling back in towards each other, just like they mapped the top of the bottom. You know,
no, Steve over at Spacebusters touched on it completely. He made a good point out of it. Like, yeah, they did this on purpose.
Yeah, it was modeled that way. It's because it's easier to model it. You know,
their heliocentric model, the Copernican model. Yeah. But you're Simon Dan, you're not giving our model a chance. That's the last thing he said to Nathan in a rebuttal. Like, yeah, we're not here to give you your model. We're just looking for the truth. We're not looking for your model.
Yeah, I just want to know what it's really doing, not your bullshit stuff.
Yeah.
So it's simple.
Yeah, it is.
It's got Pink Floyd on it.
Nice.
It's a good video. But he shows the fact that that's not far away. You can see the mirroring. Yeah, what's that, inferior mirage?
That can't be more than 30 meters away almost. They're right at water level, aren't they?
Yeah, low. So you can catch the effect.
Moving though, ain't it?
That's like an Aussie boat.
10 years have gone behind you. No one told you when to run. You missed the starting gun.
Get a little mirror right there. Like still playing that nice.
Catch up with the sun sinking, racing around, come up behind you again.
Well, that was short.
The sun is the same in a relative way, but you're older. Shorter of breath, and one day closer to death.
Okay, now when you're talking about these stations and the longitude and latitude, if you look at it on an azimuth, 24 hours is probably a great distance across an azimuth. Like the sun's traveling a shorter distance closer you get to north, correct? So a 24-hour period, the further you go out, would be a longer stretch for the sun. So if you're watching that clock that's geared to GMT time, right? Greenwich Mean Time. Yeah, the 24-hour distance between the north and the south, there's a huge difference, right?
Yeah.
Yeah. So the
'Cause
sun is
Walter,
going to
how
be
many-
if they're longer.
How many extra time zones are there in the South? It's some ridiculous amount. Isn't it
Yeah,
like
so they have
5
to
or
crunch
6
them all
or
together
something?
too. So that's where the Tom Foolery goes on. The 24-hour footage of the sun in the south. Wow, that's amazing. Yeah, you get my point. But I mean, to get the sun to do what it's supposed to do on a globe, and that's what Rory puts out there. What you're supposed to get the sun doing on the globe, which if you don't, you'll get it running a circuit. It'll set, it'll rise. That's the point. And that's why I'm going down there. I don't care what kind of 24-hour footage they got from a webcam in the middle of nowhere at this one little base. It stays up for 24 hours. And that's not the point neither. I should go look at it. Yeah, no, I'm not going to. I'm going to go down and do what I'm going to do. Anyways, what do you think, D-Man? This is a good one? We did a nice little 3 little videos there. It wasn't too bad.
It was pretty good.
Short but sweet.
Not bad. Yeah, it gets to the point, just so you can see the effect. I mean, it's kind of cool that that you can use like a little kid's toy RC boat and throw it in some, some small body and still get the same effect. It's kind of interesting. I don't know. Over the water is, I think, probably the most difficult because there's more things happening over the water, refraction and mirroring and mirages and all kinds of stuff, plus that nasty layer that's above the water. Once you get over to the convergence point, it starts doing all kinds of funky things, especially if it's far away. It's doing all kinds of, like I said, doing it, I mean, you can get a similar effect, I think you can, over, like a really hot highway, where it gets that heat effect from the, it's getting that rising heat effect from the hot top, from the black top. It can create a shit zone over it that kind of gives you that weird, where it disappears, where it gets that like weird zone where stuff just kind of disappears and you can't see the road past it. You know what I'm talking about when it goes over, like
Ask
if
you
you
later.
yeah, yeah, it gets that crappy ass layer where like you're getting a lot of shit happening off the surface. It's either evaporating or heat's
This
coming
is where
off.
all the gases are produced to begin with, right?
You know, but I mean, when you think about it, that's all you're really seeing is you're just getting optical effects from, you know, from adjust the angle and then the effect changes. You know?
I've heard it called diffraction when the light gets bounced off several different gas particles and stuff, water particles. It's going to do different things. It's going to block your vision. Yeah,
heat. I mean, heat. Just heat off of the surface of the hot top. You know, you're out in the desert. You stop. You're on a nice flat road. You take the camera, drop it down on the ground, and you'll see it. You'll see the heat. You'll see the heat coming off the hot top. You know, it isn't any different. Well, do you think that's going to affect how you see things past that point? Absolutely. It's the same thing at the top of the surface of the water, except now you're adding 3 or 4 other things to it. You get mirroring. You're getting all these effects to it. It doesn't mean that boat isn't still going, you know, flat and level of as level as it can over the water. It's chopping and moving, and you know, but I mean, it's still, the boat is still doing its thing. It's just the effect that you're seeing as you're seeing it going away from you. You're not going to see it forever.
True that. I'm just wondering who this Bob North guy is. I'm going to look him up right quick, see how big of a troll he is to a point or a sock account. Let's see.
Truth Warrior says, "Save your money and go someplace warm."
This looks like a sock account for sure. Let's see. Join September 28th. Yeah. With the name Bob North. Yeah, sound legit. 100%. Who are you, Bob? What's your real name? He's not going to say, I'm sure.
I don't know. I've been sticking to that stuff just because everybody's been kind of talking, showing videos and stuff. Like I said, I saw that Globebusters one, which is a great one. Yeah. You know, and we played a little of that, and some of the time
we'll do that next time.
Yeah, we'll go to the refraction part of that, and we won't do the whole thing, but we can do. I'm gonna rewatch it, and what I'll do is I'll take some notes where to start, so that way we can skip some of the smaller stuff and get to the meat and potatoes. You know,
the meat and potatoes. It's like a shepherd's pie. Well, I want to go get some sleep. I got to work tomorrow.
Right,
how about you, D-Man?
No,
you're off.
No work. Yeah, I'm chilling out. I got some stuff. I'm going to work on that editing machine tomorrow. I'm going to finish it up tomorrow. I did a little this morning because I was up like crazy early. I only got, for some weird reason, I was tired. I went to sleep. I woke up 3 hours later, still tired. Like, why? Why did I just wake up? So I stayed up and went and did some errands and did some stupid stuff and said, all right, I was home. I had something to eat. And then like 2 hours later, I fell asleep and then woke up at 4 this afternoon. So my sleep is all screwed up.
Okay, hold on. I asked Bob, what pure fact is who is TF? I have no idea who that is. Anyways, I didn't block anybody for presenting a mere fact. That's not why anybody gets blocked. Somebody's going to get one little nuance that they think they got you with, and then come in and reiterate it over and over again. And then when we point out facts within their paradigm that don't match up, they get mad about it, and then they go off on tangents and stuff.
Yeah.
Nobody's blocking anybody for fact posting. Who's posted a fact? Where? I don't know.
I don't know. I've been stuck on the physical side of it. That's kind of where my mind's been, just the physicality of it, the physicality of flying, the physicality of you're in the boat, you're going away. I'm standing behind the boat as you sail off away from me. You know, the physical parts is what I've been kind of sticking to lately, just because I think it's the most pertinent thing to show. I don't know. It's just my thing. I might do some stuff maybe in the springtime. It's too late in the season to do it now, but maybe over the winter time, I might buy some equipment and maybe I'll do some, because I have the Atlantic Ocean right down the road. So, I could go out and do some observational stuff on the water. There's some lighthouses and stuff out there that I can.
Nice.
Yeah. So you never know. I might go and do some stuff maybe in the springtime once the weather starts pulling up a little bit. I'm not going to go out there in the summer. I could, but it'd be interesting to do it in the colder temperature. The other thing I was looking at too, I wanted to send you a link to. I know it isn't like a crazy thing, but I was looking at. Oh shit! What did I do with it? Oh, I know this isn't a crazy camera, but I saw this today. It was really cool.
Oh, nice.
Send you this
We'll
link.
get it.
It's a thing that goes on. It's like a camera that plugs into the bottom of an Android phone. It's a like one of those thermal high resolution thermal cameras.
Okay.
And
I get the link for it. Yeah.
yeah, save it and check it out another day, man. That was actually pretty cool. I've never seen one of those. I know they probably use it for heating, or they use it for detecting heat, or looking at that kind of crap. But I saw that and I was like, oh wow, I never knew they made anything like that. Pretty interesting.
Yo.
What's up, Scott?
How's it going, Scott?
What's going on, dude? It was so funny when you said, "Which one of you two works for the head cake eater?" And I was like, I was thinking about it like it was like a mob movie, and you're like roughing up two guys. You're like, all right, you tell me now, which one of you two works for the head cake eater? That is hilarious.
So
who are these characters? Who are they? Just out of nowhere?
Yeah, just popped in. Brand new.
Yeah, because I saw one of them has one sub, so that's a sock puppet account.
Yeah, the other one I got nothing. Yeah,
I didn't check Bob though.
Yeah, Bob. He started his on the 28th, I think, and there's no subs, no info in there. He hasn't looked at anything on
Yeah,
YouTube.
somebody just slapped it together account.
Yeah, that's what they do.
Yeah, and Jaron went through the webcam thing that the Alphabet Soup organization throws out there. Like, how come you don't have a 24-hour feed?
Yeah, he did that whole thing. That's what I was going to say right before they went down there.
Yeah.
He
said
they cut it off every time.
Yeah,
they cut it all the time. Yeah.
Yep. Every time the shadow went around to a certain point, off.
It starts over again. Well, we don't have the bandwidth. I've heard that.
Bullshit. That thing's running all the time. They could simply just record it and put it onto a DVD.
Yeah.
For one day.
They could put it on a hard drive too, for that matter.
Yeah. I mean, he offered to do it. He said, "I'll send you a hard drive. Just take it and plug it right in, and then just take the hard drive and put it in, and just mail it back to me." And they were like, "No."
They take all the mystery out of it. You wouldn't have to do anything.
That's it.
So when another stupid thing that guy said, whoever, I think it was Bob, but that the 8 inches per mile squared is not it's a geometric freaking calculation according to a circle. It doesn't even matter if it's a sphere or not. It's a circle.
No, it doesn't.
Obviously,
the sphere is a circle in every angle.
In direction,
so
it's in a linear, the linear path or whatever. So I don't understand why people say things like that.
It's a circle everywhere.
But I'm just saying, like, he's like, oh, it doesn't really work that well. Like, what are you talking about? Like, it doesn't make any sense.
No, it doesn't.
So things like that only work when it's convenient to them.
Of course.
Like, it's like when you show them something, they're like, oh, well, it doesn't always work perfectly. It's so dumb.
Yeah, and there's nothing in nature that's perfect. Anyways, it is a well-oiled natural machine. It's surprisingly that nature takes care of itself. But but other than that, like when it comes to the symmetry of it all, there's nothing that's completely symmetrical, man. Go out and look at a rock in your yard. Tell me how symmetrical that is. Yeah.
How many?
Yeah, actually, there is, like, how they say there's no 90 degrees in nature. Like, there's no 90-degree points, because everything is like off a little bit, or whatever. And like, there's no straight lines in nature. They say that a lot too, but there is on a microscopic scale when it comes to crystals and stuff. Crystals are like perfect.
They're awesome. Yeah.
Geometry. Yeah.
Oh, wait, by the way, Simon and Dan missaid something the other day. It's pretty funny. Like this, they did. They measured the Earth to a geoid. He said it just like that.
Simon Dan said a geoid.
A geoid. Called it a geoid.
Isn't that one of those rocks that they bust open?
Yeah, you break open, you've got the crystals
inside.
In it. Yeah. It was just funny to listen to. He's fighting with Nathan.
Wait,
right now.
was he calling Earth a geoid? Is that what he was saying?
Yeah, that's what I'm saying. That's what he said out loud. You can look at his last rebuttal to Nathan. Nathan's telling him, it's measured flat 50 miles plus, but it's only measured flat like a Home Depot. Earth is like
back
the
to
Home
the Home Depot.
Yeah,
Jared was caught on the Home Depots. I mean,
he was saying that before he even went down there.
Yeah.
Wasn't he? Didn't he?
Yeah, he did.
He's like, well, if you set up a Home Depot, then there's just a bunch of Home Depot. I was like, what are you talking about? That doesn't make any sense.
He was talking about, I think about about how big a Home Depot is. You know how big they are.
Yeah.
Well, for them to make the foundation of that, how big it is and how flat it needs to be. If you took the Home Depots and just linked them side by side by side by side, and I think that was the idea, is that take all these
eventually
Home
you'll
Depot-
run into curvature is what he was trying to say.
eventually it's going to be you're not going to be able to even keep it flat anymore at a certain
Yeah, it's
distance.
gonna have a tolerance to it. Yeah,
It's going to have
the way
to. But I mean, when you really think about it on a globe, everywhere you're standing is flat. So if I move on that angle, okay, my body is angled, but to your relative position, where you're standing is flat. Everything away from you is an angle. Everything is dipping down from everything from you where you would be standing. So I mean, if you built a foundation here and then moved a mile that way and built a foundation, would it still be? Could you take the two foundations and literally say, okay, they're both perfectly flat? No, because you're now building it to it. You're now building it to where that flat spot is, and now everything away from the flat spot is curving down and away from you. So I mean, you would have to tilt it. Every building that they would build that would be standing up would be tilted away from.
Reciprocating depots.
If you saw a bunch of buildings,
that's what they call lean away. They call it lean away.
You'd be tilting away from each other. Even if you were standing at a downtown, and let's say you were 3 or 4 miles away, and you're looking at a downtown of somewhere that has all these big buildings, even the buildings being only a quarter of a mile away, they wouldn't be perfectly straight next to each other or behind each other. They would all be tilting away from each other at different angles. It would look like a clusterfuck. You'd be like, oh wow, look at all the buildings, they're all tilted away.
It would be like that everywhere, man.
Everything would be that way.
You could totally measure that too. You know what I mean? Like you can measure the tops of, you can measure to the point on the top of a building to another building, and then measure the bottom of the building to the other building, and within precise millimeters. Not even millimeters, even smaller than millimeters. They can do that. And guess what will happen? They're going to be the exact same freaking distance because they're equally leveled. 5 miles away, 10 miles away, 20 miles away.
Yeah,
that's what these people don't understand.
They've done these before. They've done observations across from buildings from several hundred miles across, and they're still perpendicular to each other.
Yeah, no matter what. And I mean, even at the distance. But think about it this way: if I've done some stuff where I built not big giant radio station towers, but push-up style towers, where I didn't have base plate perfectly right. I had a 35-foot Cushcraft push-up tower. This was way back in the early 1990s. And I didn't have the base plate shimmed perfectly right. So what happened was we put the thing up. I set up all the guidelines. We set up the guidelines off of it. We measured them all out, so that all the guidelines were the same. We pushed it up, and one side of the guidelines were loose, and one side was way too tight. And I'm like, why? This thing, it looks perfect. But we took a little measurement and realized that thing was off by a CH on the bottom on the base plate. But by the time you push that mast up, a friggin' centimeter on the bottom is a friggin' foot when you hit the top. So we put it up and we looked at it from one side and it looked perfectly straight, but then you'd roll around it and look at it and you could see it leaning. I'm like, wait a minute, why is it that much off? It's because as you start to go higher and higher and higher, you're now taking that mass. Now that 1 millimeter at the bottom is some insane distance at the top. So it has to be perfect. It has to be perfect to get that. So what we had to do was we had to take the whole thing down, pull all the wires off, then put shims underneath the base plate to tilt it over a little bit so that we could get it as straight as we can get it, so we could tighten those guy lines down so the thing wasn't tilted over. I mean, even if you think just 35 feet, what's that, 3 stories? A little over 3, you figure a story on a building is what, 10 feet? So, I mean, even if you figure that okay, yeah, you go 3 stories up, if that building is off just by a millimeter, you're going to see it at the very top. You'll notice that it's leaning. I mean, you won't notice it when it's only a foot off the ground. You wouldn't notice it at all. You'd be like, okay, yeah, that's straight. But lift it up 35 feet. And I remember the guy telling me, he said, the base plate's off. We got to shim it to bring it over towards. Yeah. So that's what we had to do. We had to take the whole thing down. We had to disconnect the whole thing, and we had to take the bolts back out and then put shims underneath underneath the base plate so that it took the plate and tilted it over just a little bit. And then we put the thing back up and then pushed it back up and walked around it, and we pretty much had it dead on. And he's like, all right, that's fine. And then we pulled the lines and then we adjusted all the guy wires for it. This is way back in the 90s. I had a big, it was called a Mako antenna, aluminum antenna on it. Got hit by lightning. And we had to take the whole thing down, the whole top section of it. The bottom of the mast was touching the very top of the thing. The electricity, could naturally went down the mast and into the base plate like it's supposed to do, because it's it has we have ground poles to it.
Yeah,
big copper ground stakes, and it welded.
They still do that now. All those towers are.
Yeah, it welded the PL259 coax connector to the bottom of the antenna. It literally welded it. I mean, that's how much nasty that electricity was that went down through that thing, and it melted all the coax. It blew the fiberglass section and just shredded that thing and just shot it out all over the yard. My neighbor's roof next door had pieces of the fiberglass just shot out like blew it up literally, and welded the bottom part of the coax connector right to the bottom of the antenna. And I was like, Pisa, do you think we can fix it? I was like, no, there's no fixing this. So we went to go take it off the top, and it literally arc welded the bottom of the antenna to the top of the mast. So we had to take the top section, just cut the whole thing off. So now it was 30 feet instead of 35. And I was like, Jesus. But I mean, if that thing is just off by a millimeter on the bottom and you go 50, you go 20 stories up, that little millimeter on the bottom, by the time you get to the top of that building, is a lot. And you will notice it if you walk around it and look at it. You know what I mean? So them saying, oh, well, everything is set at center and, where it's like, no. If that was the case, even just going 4 feet over the foundation would have to be tilted to the curve, to the curvature of what it's on. And if you were to center everything, well, everything wouldn't be perfectly straight up and down. You would see the tilt in all the buildings and everything, and you don't see that. I could go down to Boston and, in 2 hours, 2.5 hours, and I could go take pictures of the skyline down there. There's none of those buildings are leaning away from each other. None of them, not one.
Yeah, the Wang feed or whatever he's talking about, a geostationary satellite, they can actually almost seems like it's stationary. You can pick it up with a radio antenna, is what you're saying? It's almost stationary. Okay, so like nothing else in the atmos would actually affect any of those radio signals or the broadcast signals from the satellite to there. I think that's what they're accounting for. It has nothing to do with the rotation of the Earth. Anyways, and this isn't a scientific topic, by the way. You can't appeal to modern science. There's nothing scientific about this. You guys have a weird way of describing science. And it never does prove anything neither. But I think science was actually formulated so you can find out the cause and effect relationship in a natural phenomenon, correct? That's what science really does. You develop a hypothesis based on your observation in a natural phenomenon, and then you get an IV and a DV and a null to get to your conclusion, to find out the cause and effect relationship. That you're trying to narrow it down by disproving one or the other.
Yep.
Yeah, that does prove things, by the way. But I mean, you guys play loose with it. Anyways,
I have an old AARL handbook. Tomorrow, when I'm out in my storage, I'm going to go and find that handbook and take some photos. I'm going to take some pictures of the insides, where it shows the ionosphere, the troposphere. It shows you how radio signals bounce off. That was what they were kicking out in the 1950s. That book is from, I think, 1958 or 1959. It's an old one. I bought it a long time ago at a book thing at MIT. Probably the 90s, early 1990s. I bought it at a ham radio fest.
Nice.
In the MIT parking garage. And I saw
like
the
a
book.
shady deal. He was a CIA down there too.
Yeah, no, MIT. Well, because there's a lot of ham radio operators that there's a lot of people that run. Actually, I think there's an amateur radio repeater on top of MIT, the Massachusetts.
I bet you there is. Yeah.
Yeah.
My dad went to school there actually. He took physics at MIT. The
Yeah,
Navy
and
paid for it. Yeah. Like,
one
hey,
of my buddies worked there. This guy I knew from the radio when I was on the radio days, and he worked there. I don't know what he did. I don't think he did any teaching or anything. I think he just worked for the school, probably doing maintenance. So, I don't know. But he was a big radio guy. He was in the ham radio shit. And me and him met up one day, and he said, "Come on, they're having a ham radio fest in the parking garage." So we went in there and walked around and looked at all the old ham radio gear and microphones and old radio stuff. And I noticed the guy had books, and I reached down and grabbed one of the books, and that was the book I bought. It was the I think it's 1958 or 1959 AARL handbook, and I've had it. I probably like I said I bought it
I
probably.
bet you my dad had one of those laying around because my dad worked for a group called Mount Mitchell, and they ran the Muzak systems that broadcast all the background music radio over the East Coast, and they handled Billy Graham's radio station from Black Mountain.
Yeah, Billy
so
Graham.
he had to map out the signals. So that's what he did. He mapped out the signals throughout, and they try to get better signals, and they put repeaters and transponders and stuff.
Yep.
It's what he did. Yeah.
Yeah, MIT I think has got a repeater. I don't remember what frequency it was, but I'm pretty sure that they have one down there because, like I said, he was big time in ham radio. I wasn't into ham radio. I was for a little while, but it was boring. I was more a CB guy. CB was kind of more fun.
I do remember my dad telling me this, though. The biggest obstacle he had to get over wasn't to do with curvature or range. It was actually the elements like granite in the mountains, sand spots in the flats. They would absorb the radio signals before they could get out. They had to get around that, so they had to put the different receivers, repeaters. Yeah,
yep,
that's the way it works.
Yep, we were talking about radar and light, radar. Radio signals, directional radio signals, especially flat side radio signals, all run into the same problems, topography. They all have problems with topography, especially flat side. Vertical or I forget what they call it, omnidirectional, not so much, but flat side meaning horizontal signals. Yeah, topography, going over topography, it's gonna bounce off of stuff. It's gonna get absorbed into things. It's so much shit affects radio, especially at lower frequency, especially at lower frequencies. Higher frequencies, they take a lot more power. I mean, those ham radio guys, some of those guys to push at some of the frequencies they do. I mean, I used to listen to shortwave radio, stuff coming from Arizona, on shortwave radio, and I'm almost in Maine. So
with FM, they just push the amps up, man. Like some of those,
big time power.
They just like 2,000 watt amplifiers actually will work.
Yeah, I had a kicker on. I had a kicker on for 10 and 11 meters. I used to talk.
Yeah, how do they explain that one though? Where you can pick up radio signals from thousands of miles away, just regular people in their car.
Yeah.
How do they explain that one?
Bringing that book for that's what the book's going to tell you about the ionosphere, the troposphere.
They say it bounces back down. Yeah.
I mean, if it's a vertical signal, meaning if it's an omnidirectional antenna stands straight up, they have shorter range, but they have they're almost like mushroom shaped. How the signal comes off an omnidirectional, depending on the frequency. But they also have what they call flat side transmitting, which is flat side means that it has no vertical direction. It simply is where it's pointed. So it's to go from car to car, a lot of times, depending on where you are. I mean, I was on top of a giant hill, so I could use an omnidirectional antenna and hear 360 degrees with equal power if you don't have anything restricting any sides of the antenna. But it gives you 360 degree equal transmission and equal receiving, meaning you can get signals in, but it's shorter range. So you have to pull the power way up. Flat side or horizontal, transmitting horizontally is more depending on what's around you. When you're, like I said, going over the water, it's flat. Being on top of a giant hill, that's good. But you're driving through the city, there's tons of building around. Flat side doesn't get out very good because it bounces off of things, and you get a lot
stronger signal. It's going to reflect off of it.
Yeah. But it's definitely topography affects it. So naturally, when you would talk on the radio with these guys that had flat side stuff, they would have those antennas way, way up in the air, or they would put them on towers. And the cool thing about flat side is you can pinpoint on beam antennas, you can pinpoint where the signals are coming from by looking at the signal meter. So you could just take the antenna and just turn the dial, and the antenna is turning, and you could just find the high side. You could just find the high signal and say, okay, yeah, I'm here and he's northwest, and you could just pinpoint the signal. Where an omnidirectional, you can't do that. So
I'm connected. All right, gentlemen, I want to ask Scott a question. You do any shows anytime soon? Have you done any music lately?
We're getting ready for a show coming up.
Nice. Maybe we can do a live broadcast. We know how broadcast works now, but we'll do our own little radio station. I wonder if they'd say anything if we did guerrilla radio.
What do you mean? Just like run a live stream?
Yeah.
Yeah, I could do that, but then it would probably kill my battery real fast. You know what I mean?
Yeah.
That's the problem.
You need Starlink.
I just put out it's a promo vid actually from my new band.
Oh, cool.
Yeah, we made a promo vid for booking shows and stuff.
Nice.
Bunch of clips.
Yeah.
You ever come to the Northeast? You ever come to the Northeast?
Not that far up.
All right, gentlemen, I want to get to bed. I do have to.
Good talking to you. Good to see you, Scott. Good to see everybody in chat too. Thanks for coming
in, Scott.
All right, guys.
Good, D man. It's been a lovely little chat we've had.
Yeah, it was pretty good. It was a neat little show. Just relax. That's how it should be.
Yeah, just get the facts out there. Don't have to, speculate on anything.
Yeah, I mean, just chit chat.
I'm gonna play Chris Berry out.
Alrighty.
He's a safe one I can play with.
Yeah, I don't know what's going to happen with that Pink Floyd thing. I didn't think about that when I threw that on there, but you never know. We were talking here and there, so you never know. It might not get chopped out. If that's the case, just chop it out. Just take it out of there.
I haven't got an email yet, so I don't think I've got it.
Pink Floyd's really they don't really like anybody using this shit.
Yeah, I don't know why. Nope. Play Chris Berry out. I haven't got one. We're good.
All right, man.
Sweet. All right. Well, I'll see you next show.
I'll next time.
See you another one. Yeah, I'll let you know. All right. Good night, guys. Thanks for stopping by, and the trolls included. I appreciate the snide comments in the back. I don't understand science.
Well, like and subscribe.
Yeah, I know.
Leave lots of likes.
And soon it'll be As the Globe Turns.
Yes, it's coming. It's coming. Dun, dun, dun. When we get to that point, then all you got to do is just play the intro. I'm even doing a graphic. So I'm even doing a graphic over the original. Yep. So it's coming. It's coming. I'm going to be working on it tomorrow.
Sweet. All right. Night, guys.
In the valley of the shadows, land of the scorpion, stung by the darkness, swimming in all the poison. I need some angel music, so damn hot down here. I need some angel music, so to wash away the fear. Come with some angel music, so damn hot down here. I need some angel music, so to wash away the fear. Holy, unseen, I plead, show me some mercy. Grandma, come on down here and sing your prayer with me. Cause I can shine like a raven if I get a little bit of sun, a little bit of light, just a little bit of sun. I can shine like a raven if I get a little bit of sun, with a little bit of light. I can shine like a raven. I can shine like a raven. I can shine like a raven in the land of the shadows, the valley of the scorpion. Stung by the darkness, swimming in out the poison. I need some angel music. I need some angel music. I want some angel music, a song to wash away the fear. Holy, unseen, I play. Show me some mercy. Grandpa, come on down here and sing your prayer with me. Cause I can shine like a raven with a little bit of soul, a little bit of light, just a little bit of soul. Black feather glisten, just a little bit of light, a little bit of sun. I can shine like a raven, shine like a raven. Black feather glisten. Pull me up from the Snake River. I want to be one. Pull me up from the Snake River.